Now we will do another problem on first law of thermodynamics. So the problem is like this: a piston and cylinder machine contains fluid system which passes through a complete cycle of four processes. During a cycle, the sum of heat transfers is given as minus 170. System completes 100 cycles per minute. Complete the following table showing the method for each item and compute the net rate of work output in kilowatt. So this cycle contains all these processes. So starting from A and finally it reaches A. So it is a cycle. So you need to calculate all these values here. Okay. And it is given that the total heat transfer is minus 170. Okay, 170 kilojoule. And it is given as it is so this is for a cycle. Okay, this is for a cycle. So everything here it is given as kilojoule per minute. Okay, this is given as kilojoule per minute, that is 21,000 minus 2,100. So that means we need to calculate the heat transfer for a cycle first. So since the sum of heat transfers per cycle is minus 170 kilojoule, so it completes 100 cycles per minute. So you can also say that Q is equal to minus 170 into 100 kilojoule per minute. Okay. So this is minus 17,000 kilojoule per minute. This is the total heat transfer. And so if you sum all these, you can get the heat transfer, that is 0 plus 21,000 minus 2,100 plus QdA. This is equal to minus 17,000. All these units are in kilojoule per minute. So QdA will be equal to so this is equal to minus 35,900 kilojoule per minute. So QdA. Now let us find delta E. Okay, so we have got it here. This is minus 35,900. Okay, 35,000 minus 35,900. Okay, fine. So what is delta E? So that can be found for process AB. You have Q is equal to delta U plus W. Here we are taking delta E, total energy, instead of internal energy, because if you account for kinetic energy and potential energy. So delta E. So that means Q is 0. So delta E plus W is 2170. So delta E is minus 2170. It is minus 2170. Okay. So this is the delta E. And here for process BC, you have Q is equal to delta E plus W. So Q is equal to 21,000 is equal to delta E plus W. Okay, so delta W is 0. So delta E is equal to 21,000. Okay. And similarly for process CD, you have Q is equal to delta E plus W. So Q is minus 2100 is equal to delta E is minus 36,600 plus W. So W is equal to, it is equal to 34,500. So this is the 34,500. Okay. So now you need to find, we will find delta E here, because this is a cycle. That means the sum of all these delta E will be 0. So you can, using that idea, you can find delta E for the process dA. So this is equal to minus 17,770. Okay. So this is delta E. Now you can find W. So that means for process dA, Q is equal to delta E plus W. So that means this is minus 35,900. So delta E is minus 17,770 plus W. So this is equal to minus 35,000. So this is equal to, W will be equal to minus 18,130 kilojoule per minute. So this is the work done, 18,130. So this is how you find the work done and change in energy of the system for each process. So we made use of this idea, that is the total energy. First we found the heat transfer for this process because the total heat transfer is given, and you have the delta E. Total delta E of a cycle will be 0. So that's another idea we used. And if you want to verify, you know that cyclic integral of Q is equal to cyclic integral of W. So cyclic integral of Q is, here it is given, that is minus 17,000. So if you add all these four, then you will get minus 17,000 itself.